In this example, we're going to take a look at what the ratio of the areas are for two given triangles. Here are triangles, triangle ABC and triangle DEF, both of which have one side length indicated. We're also given that triangle ABC is similar to triangle DEF. Therefore, we know that the ratio of the corresponding sides is going to be equal, and we can set up this proportion. Or, if we refer to the side lengths as lowercase letters rather than by the vertices of the triangle, we can set it up such that opposite to angle A is lowercase a or side A, opposite to vertex B is side length B, and opposite to vertex C or angle C is side length C, and similarly with the smaller triangle. So we have the proportion A over D equal to B over E, which is equal to C over F, and again those refer to the sides of the corresponding triangles. Now if we take a look at the information that's given in the question, we know that side BC, or we'll refer to that as being side A, has a value of 8 centimeters. And side EF, or we'll refer to that as being side D, has a value of 6 centimeters. And if we extract those two sides from the illustration and set it up in our ratio of BC over EF, or A over D, we'll get the ratio of 8 over 6, which can be reduced to 4 over 3. Again, this is the ratio of the corresponding sides given in the illustration. Now let's take a look at the ratio of the areas for these two triangles. And we can set up our ratio of the larger triangle over top of the smaller triangle. And we know that the property of the ratio of the areas is that it's going to be equal to the square of the corresponding sides, the ratio of the corresponding sides. So we can set it up such that we have side A squared over side D squared, and we'll sub in our values that we know. We know that side A is across from angle A, which is 8 centimeters, and we've subbed it in the top. And we know that side D is across from angle D, which is 6 centimeters, and we've subbed it in the bottom. When you square those two values, you get 64 over 36, which can be reduced to 6 over 9. What you may have noticed is that, in fact, the ratio of the corresponding sides given in the question squared will give you the ratio of the areas of these two triangles. Again, compare the two values that are circled here. 4 over 3 squared would give you 16 over 9. Or another way of looking at this is by taking a look at the smaller triangle on the top and the larger triangle on the bottom. Just reversing your ratios will give you a ratio going the other way of 9 over 16.